Welcome to today's deep dive, everyone. Usually when we think about the technology we use every day, we kind of picture it like a highly trained, really eager golden retriever.
Right, yeah. Just sitting there on the rug, tail wagging, totally waiting for you to throw the ball.
Exactly. I mean, you have to actually initiate the game. The machine is, at its core, just a reactive tool. You push a button, it does a thing.
It operates entirely on this binary of prompt and response. The technology basically has no agency until you provide the friction of a command.
But looking through the stack of research for today, specifically this daily AI news digest dated today, May 29, 2026, the golden retriever is just, well, it's entirely gone.
Yeah, it really is.
We are looking at a technological landscape that has completely shifted its posture.
Hmm.
It's no longer waiting for us to throw the ball. The system is already running to the exact coordinates where the ball is going to land, long before we've even pulled our arm back to throw it.
Which is, we are documenting the absolute definition of a paradigm shift here. Artificial intelligence is evolving at just a breakneck pace from a reactive utility into this predictive ambient partner.
Ambient partner, I like that.
Yeah, it's the transition from doing what it is told to anticipating what will happen next. And if you look closely at the developments in this single daily digest, you can trace this predictive evolution operating across multiple dimensions of human existence simultaneously.
So let's pull the thread on that, starting at the absolute largest dimension possible, which is global public health.
Right, the macro scale.
Yeah, the very first breakthrough in today's digest is this massive development out of a leading university. They've deployed an AI model that forecasts potential disease outbreaks and epidemiological hotspots before they even happen. Like they're aiming to stop pandemics in their tracks.
Notice the operational shift there. For the last century, public health has been locked in this purely defensive posture.
Oh, for sure.
A novel pathogen emerges, people start arriving at hospitals, and then traditional epidemiologists work backward to identify the source, and then we scramble to contain it with quarantines and vaccine development.
Right. It is fundamentally a race against an event that is already unfolding.
Exactly. But this AI model is attempting to shift public health to an offensive posture.
And what really stands out to me in the data is what the AI is actually analyzing. Like, it's not just looking at swab results from a clinic somewhere.
No, not at all.
It is ingesting vast matrices of environmental factors and human activity. But, why would an infectious disease model need to look at shifting climate patterns or urbanization?
Well, because a virus, on its own.
I mean, I always pictured virologists deeply focused on the biology, looking for mutations under a microscope. Why is this algorithm studying global flight manifests instead of just studying the virus?
Because a virus on its own is just inert biological material. A global pandemic is not merely a biological event, it is this incredibly complex sociological and ecological collision.
Ah, I see.
Yeah, a highly contagious pathogen mutating in an isolated, static community will just burn out. To become a global threat, it needs a vehicle.
It needs a densely packed transit hub or like a population that commutes across borders every day.
Exactly. It needs specific atmospheric humidity for the carrying vector to survive. It needs human encroachment into a previously isolated wildlife habitat. And it needs a global supply chain to hitch a ride on.
That's a lot of variables.
Too many for us, honestly. Traditional human epidemiology struggles immensely to model all of those chaotic, non-biological variables at the exact same time. We tend to isolate variables to study them.
Right, to make it manageable for the human brain.
Right. But the artificial intelligence doesn't isolate them. It feeds the microscopic mutation rates, the macroscopic flight patterns, the deforestation satellite imagery, and the regional temperature fluctuations into a single massive neural network.
It's like having a highly accurate weather forecast, but for viruses.
That's a great way to put it.
Instead of just telling you to bring an umbrella, it tells health organizations exactly where to send vaccines and resources.
Yeah.
So it's performing this multivariable pattern recognition on a planetary scale.
It finds the hidden mathematical correlations between, say, a season of heavy rainfall in one hemisphere and a surge of hospital admissions in another.
Wow.
It calculates the exact probability of an outbreak's origin point and its most likely vectors of transmission. By analyzing the atmospheric and sociological conditions, it can tell global health organizations exactly where to pre-deploy vaccines and medical personnel weeks before the pathogen ever reaches critical mass.
So it's taking the chaos of the global environment and rendering it mathematically predictable. which makes the next development of the digest so fascinating because we are taking that exact same predictive logic, that immense computational power, and turning it entirely inward.
We zoom all the way in.
Right. We are moving from protecting the global population using planetary data to protecting you, the individual, using your most intimate microscopic data, your DNA.
The underlying mechanism of predictive modeling remains the same, but the dataset shifts from the macro to the micro.
Yeah, so there is a story here about a biotech company unveiling a new AI-driven platform for personalized medicine.
This one is huge.
It is. The platform customizes pharmaceutical treatment plans based entirely on a patient's unique genetic makeup. And the source promises faster recovery times and, virtually eliminating side effects.
To appreciate the mechanics of this breakthrough, we really have to acknowledge the inherent flaw in how modern medicine has operated up until now.
The trial and error approach.
Exactly. For decades, we have relied on the randomized clinical trial. We test a chemical compound on a broad demographic, and if it cures the ailment for the majority of the statistical bell curve, it gets approved.
It's one-size-fits-all medicine based on statistical averages.
But human bodies aren't averages. We possess entirely unique metabolic pathways encoded in our DNA. When you take a standard medication, your liver utilizes specific enzymes to break down that chemical. Think of your liver enzymes as a highly complex set of tumblers in a lock. Standardized medicine is essentially a master key. It's designed to roughly fit as many locks as possible.
Yeah, that makes sense.
It might turn the lock and cure your headache, but because the cut isn't perfect, it scrapes the tumblers. Those scrapes are what we experience as side effects, nausea, fatigue, or worse.
And a drug that works perfectly for me might cause a severe adverse reaction in you simply because your genetic code built a slightly different set of tumblers.
Precisely.
It's like the difference between buying a suit off the rack and having a master tailor make one just for you, but the measurements are your genes. So how does this new AI platform actually solve that biological friction?
Through the field of pharmacogenomics, accelerated by machine learning, sequencing a human genome produces roughly 3 billion base pairs of data. A human physician cannot possibly sift through that ocean of genetic information to determine exactly how your specific liver enzymes will metabolize a standard dose of blood pressure medication.
Yeah, the human brain just cannot hold that much raw data in its working memory.
But the AI platform can process those 3 billion base pairs in seconds. It maps the exact shape of your metabolic tumblers and cross-references that map against vast global databases of pharmacological interactions.
So it's not just guessing.
Not at all. It doesn't just guess what might work based on a clinical trial. It predicts the exact chemical interaction that will occur in your specific body before you ever swallow a pill. It cuts the medication profile to fit your exact biological shape.
I look at a breakthrough like that, and to be honest, my immediate reaction is a bit of skepticism about accessibility.
That's fair.
Whenever a new technology promises bespoke, genetically tailored anything, it usually comes with a massive price tag. But realistically, if this requires deep genetic analysis and complex algorithmic modeling for every single prescription, is this something that will actually be accessible to the average person anytime soon? Or is this faster recovery just for the ultra-wealthy right now?
Well, the initial rollout of deep tech always carries a premium, sure. But we have to look at the economic trajectory of the underlying tools. The physical cost of sequencing a human genome has plummeted from billions of dollars in the early 2000s to a few $100s today.
Oh, wow. Yeah, that is a huge drop.
The physical data acquisition is cheap now. The historical bottleneck was the computational brain power required to actually analyze that genetic data and apply it to a treatment plan.
You would need a team of geneticists and pharmacologists working for weeks on a single patient.
Exactly. The AI eliminates that labor bottleneck entirely. It automates the analysis. By removing the trial and error process of prescribing medications, and by preventing the incredibly expensive hospitalizations caused by adverse drug reactions, this predictive platform actually introduces massive deflationary pressure on healthcare costs in the long run. The source really positions this as a systemic shift in how we approach treatment broadly.
Okay, so we've gone from artificial intelligence predicting the massive chaotic environment around our bodies to predicting the highly specific chemical interactions inside our bodies. Now, looking at the third major development in today's digest, we are seeing this technology begin to anticipate how our bodies navigate through the external physical world.
Yeah, we are transitioning from biological systems to mechanical physics.
Right. A major car manufacturer is rolling out a new machine learning AI system integrated directly into their latest vehicles. The stated goal is enhanced safety and efficiency, acting as a vital stepping stone toward fully autonomous vehicles.
A huge stepping stone.
What the operative phrase they use is that the system doesn't just react to the road, it predicts and responds to potential hazards like sudden stops or unexpected obstacles before they materialize.
The distinction between deterministic algorithms and probabilistic neural networks is vital here.
Break that down for me because, cars have had collision detection for years, right? My car has sensors that beep aggressively if I tailgate someone, or it will automatically hit the brakes if the car in front of me slams on theirs. How is this new machine learning system any different than the safety features we already have?
Well, the systems you were describing rely on deterministic algorithms. A radar or LiDAR sensor bounces a signal off the bumper of the car ahead of you.
Right.
If the distance between your vehicle and their vehicle closes at a rate that exceeds a pre-programmed threshold, the algorithm triggers the brakes. It is an if-then command, but it is fundamentally reactive.
Because the danger is already happening.
Exactly. The hazard, the sudden stop, already exists in reality. The machine is merely reacting to the danger a few milliseconds faster than your human reflexes can.
It's still just playing catch-up to the physics of the crash.
A probabilistic machine learning system, though, shifts the vehicle into the predictive realm. It doesn't wait for the car in front of you to hit the brakes. The AI is continuously processing visual and spatial data from a 360-degree array of cameras and sensors, tracking the micro-movements of dozens of vehicles simultaneously.
Dozens of them.
Yes. It notices that a car 3 lanes over is oscillating within its lane by a margin of 2 inches. It registers a slight erratic fluctuation in that vehicle's acceleration curve, and it factors in the current ambient temperature and the reduced friction of a wet road surface.
So it's taking all of those tiny, seemingly insignificant data points and calculating the physics vectors in real time.
It is running thousands of micro-forecasts every second, calculating the complex probabilities of where all those moving objects will be in the near future. It determines that, based on the erratic micro-movements of the car 3 lanes away, there is an 80% probability they will swerve into your lane in exactly 3.5 seconds.
That is insane.
So your car gently adjusts its speed and road position to ensure you are no longer in that physical space when the event occurs. It is predicting the physics of a crash before the hazard ever materializes.
Okay, I have to challenge the idea of a machine completely taking over that process, though.
Yeah.
Because human drivers have a sort of gut feeling,
Sure.
Like you look at a car swerving a half mile ahead and intuitively know that driver's erratic before they ever become a direct obstacle. You just ease off the gas. Can this machine learning algorithm actually replicate that human intuition of a hazard? Or is it just reacting to sudden stops a split second faster than a human foot can hit the brake?
We have a tendency to romanticize human intuition, treating that gut feeling as some mystical sixth sense. But neuroscientifically, intuition is just subconscious pattern recognition.
Oh, really?
Yeah. Over years of driving, your brain has built a neural network trained on thousands of hours of highway data. When you sense an erratic driver, your brain is processing subtle visual cues like the angle of their tires, their speed relative to the flow of traffic, without you actively thinking about the math.
So my driving intuition is literally just meat-based machine learning.
That is the biological reality, yes. You have trained your own neural net. The advantage of the artificial neural net is that it doesn't experience cognitive fatigue, it doesn't get distracted by the radio, and it possesses a flawless 360-degree field of vision.
It doesn't blink.
Exactly. It is replicating the exact mechanism of your human intuition, but it's doing so with quantifiable data points and at a scale of processing power that the human mind simply cannot sustain. It takes the nebulous gut feeling and renders it mathematically actionable.
It's quantifying intuition to engineer the danger out of the physical world. Which leads us perfectly into the final environment covered in today's deep dive. We've moved from the planetary ecosystem to the biological body to the moving car, and now we arise at our most intimate space, the home.
The final frontier.
Right. And here, prediction transforms into pure intuition.
We are moving from navigating physical hazards to navigating behavioral routines.
So a tech startup has launched a new AI-powered home assistant. And the digest makes it clear this is not a smart speaker you yell commands at across the kitchen. The system utilizes continuous behavioral pattern recognition to learn your daily habits.
It's always learning.
Always. It integrates seamlessly to offer automated controls for lighting, security, temperature, and media. The explicit goal is to make the home completely intuitive, not just smart.
We have to contrast this with the first generation of smart home technology, which was, quite frankly, an exercise in manual labor.
Oh, absolutely. You had to explicitly program everything. Turn on the living room lights, or clapping your hands, or setting rigid timers for the thermostat.
First-generation smart homes relied on the exact same conditional logic as early car safety systems. If the user issues a specific vocal command, then execute the function. But that dynamic still required the human being to carry the cognitive load of managing the environment.
You were still the manager shouting orders at a digital butler.
The friction of the command remained. What this new iteration of AI does is eliminate that friction entirely through ambient computing.
So we are moving from having an obedient, robotic butler who waits for you to shout an order, to having a hyper-observant roommate who just knows you like the lights dimmed and the doors locked at exactly 8 p.m.
It creates a frictionless domestic environment. The AI stops waiting for you to cue the music or adjust the thermostat. You walk through the front door on Tuesday at 6 p.m., and the physical environment has already rearranged itself to meet your psychological and physical needs before you even realize you have them.
It predicts your comfort based on your life's pattern.
Exactly.
But I mean, at what point does an intuitive house stop feeling helpful and start feeling a little too observant? A helpful roommate is great, but a roommate who watches you so intensely they know you're going to the kitchen for a glass of water before you've even stood up from the couch, that kind of borders on surveillance, doesn't it?
You are identifying the fundamental tension at the core of the entire predictive AI revolution right there. In order to construct a frictionless, perfectly intuitive environment, the algorithm requires a continuous, massive stream of intimate data. An AI cannot predict your behavioral needs if it does not constantly observe your habits.
It needs the sensor data to build the probabilistic model of my evening routine.
Yes. The inescapable trade-off for a house that perfectly anticipates your desires is a house that is constantly watching you. It completely challenges our historical expectations of privacy within our own walls. We are trading the friction of daily tasks for the friction of total observation.
That is a wild trade-off to think about. Let's step back for a second and look at the massive narrative arc we've just unpacked from a single day's news cycle.
It's been quite a journey.
It really has. We aren't just looking at random tech upgrades. We are witnessing a fundamental rewiring of how systems interact with humanity. We've explored AI mapping atmospheric data to forecast global diseases before they strike.
Right.
We've seen it analyze billions of genetic base pairs to predict how a chemical will interact with our unique liver enzymes. We've watched machine learning calculate physics vectors to anticipate crashes before tire slips. And we've seen ambient computing observe our private habits to intuitively manage our living rooms.
The thread connecting all of these distinct developments is that artificial intelligence is no longer a distant technology happening around you. It has become a pervasive, predictive layer actively learning about you. Its explicit function is to observe, calculate, and optimize every scale of human existence for maximum safety and maximum efficiency.
From the macro survival of the species to the micro comfort of your Tuesday evening.
Exactly. It aims to smooth out everything.
It is actively calculating the future to smooth out the present. Which leaves us with a lingering question to explore, something for you to mull over that builds on today's deep dive. If AI eventually reaches a point where it can perfectly predict our health, our hazards, and our daily household routines to keep us perfectly safe and efficient, what happens to human spontaneity?
That's the real question. What is the cost of a perfectly frictionless existence?
Right. If every moment of friction is predicted and smoothed over by an algorithm, do we lose the messy, unexpected accidents that actually make life interesting? It makes you wonder if, eventually, we might actually miss that untrained golden retriever just sitting there waiting for us to initiate the game. Thank you for joining us on this deep dive. As always, keep questioning the systems around you and stay curious.